Okay guys, so in this video, I'm going to talk about the efficiency of public good. Is it efficient to own or to have the public good or not? So how do we decide that? Well, I'm going to give my arguments in the most general framework, and then in the follow-up videos, I'll solve a numerical example. The reason we and I give some of our arguments in a more general framework is just to show that the arguments that we make are not specific to some specific utility functions or values. All right, so it's a general argument. And so for that reason, in order to not bound you with specific examples, we try to make our arguments in the most general framework. Well, here, let's remember our framework. So we had two agents, and these agents have utilities over their private consumption and whether there's a public good or not. All right, and there's also agent 2. So remember, the G takes the value either 1 or 0. 1 if there is a public good and 0 if there is no public good. And XI is basically their initial wealth minus how much they contribute. GI is the amount of contribution. Okay? So we already talked about the reservation price. So the reservation price, we use a different notation for reservation of price than GI because it's special. You'll see why. Reservation price is basically, I'm sorry. So the reservation price is the utility of agent 1. When this is his private consumption, when he pays his reservation price and G is equal to 1, is exactly equal to his utility. If he basically pays nothing for public good and the public good doesn't exist, and the utility of agent 2, when she pays off the reservation price, this is how much private consumption she can afford, but luckily she has the public good, versus her utility when she doesn't have to pay anything for the public good because the public good doesn't exist. So the R1 and R2, which solves these two equalities, are called the reservation price, which is something we already discussed in the previous video. Okay, so what I will do now is, so remember here there are two situations. A public good or not. So what I mean by not, I mean we implement the public good versus we don't implement, or we build the public good versus we don't build the public good. Remember, the public good costs C dollars. So the thing is, a public good or implementing the public good is Pareto superior, and therefore Pareto efficient, because here we have only two options, build the public good or not build the public good. So the public good is Pareto superior over not having the public good if utility of agent 1, when there is no public good, is less than or equal to his utility if the public good does exist. Well, how much money he spends, I don't know, some $1. And the utility of agent 2 when, she doesn't spend any money on public good because the public good doesn't exist, should be less than or equal to her utility if she in fact spends some money on public good. So her private consumption is X2, which is, remember, less than W2 or equal to, depending on G2. So the public good is Pareto superior if there is some contribution, G1, G2 greater than or equal to 0, such that both agents get happier if they have the public good. All right? In comparison to which scenario? In comparison to scenario where there is no public good. All right? So both agents are happier. Well, the thing is, what if, so these are less than or equal to, so what if they both are equal to? So one of the inequalities is strict. Okay? So once again, building the public goods is Pareto superior means we are comparing two scenarios. In the one scenario, there is public good. In the other scenario, there is no public good. So the public good is Pareto superior over no public good. It means the agents, both agents' utilities are higher when there is a public good than their utilities when there is no public good. All right? And if they both are the same, it means they're indifferent between having public good or not having public good. So one of those inequalities should be strict so that one agent is getting strictly better off. All right? So the thing is, what am I going to do with this inequality? So does this inequality tell me anything about the reservation price? And in fact, it does. All right? How so? Well, okay, so what I'm going to do next is to manipulate these inequalities in order to rewrite this whole sentence. You know, public good is Pareto superior if blah, 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 blah. So I'm going to write this blah, blah by using the reservation price. Okay, so reservation price and the cost of implementing the public good. Remember, G1 plus G2 greater than or equal to C is when the public good should be built, otherwise it shouldn't be. So I'm going to basically relate the C and the reservation prices and this statement. So how do I do that? Well, simple. Well, first of all, look at the right-hand side of these two inequalities. Well, these are just, I use the budget constraint, all right? So the budget constraint, the x1 is equal to w1 minus g1. So g1 is the contribution. That's it, g equals 1. And so the reservation price doesn't kick in here. So again, I am just using the budget constraint. So x2 is the private consumption, which means basically how much money she's gonna left with if she contributes G2, and then capital G is equal to 1. Well, what matters is the left-hand side, all right? So the left-hand side, in order to manipulate this, I'm going to use the reservation price, the definition of reservation price. Remember, the W1 G equals 0 is exactly equal to this utility for agent 1. So W1 minus R1, G equals 1. Okay? Now, I do the same thing for agent 2. So utility of agent 2, W2 minus R2, G equals 1. All right? Well, you may wonder, why do I do something like this? Well, because now I have, when I look at this one inequality, so let me use a different color, okay? So if I use a different color, so let's focus on agent 1's inequality here. So here on the left-hand side, I have the utility of agent 1 and the utility value when G is equal to 1. And on the right-hand side, I also have the utility value of agent 1 when G is equal to 1. All right? So basically, I have U1 something comma G equals 1 greater less than or equal to U1 something else, let's put star, G equals 1. All right? So the G's are the same. This dot and the stars are different. What I know is that the utility functions are increasing. So therefore, if this utility value is higher than this utility value, well, then this star thing should be greater than dot. Okay? Because the utility functions are increasing. So that's basically what I will use. So from the first inequality, what do I get? W1 minus R1 is basically less than or equal to W1 minus G1. And here you see why I don't want to leave it as X1, but rather write it W1 minus G1, because those W's are going to cancel out. All right, so there's going to be no wealth effect. Okay, so from the second agent's inequality, I have W2 minus R2 should be less than or equal to W2 minus G2. Remember, one of those inequalities must be strict. All right. Well, but from these two, what do I have? The W's will cancel out. I mean, W1 and W1 will cancel out. W2 and W2 will cancel out. So this is minus R1 minus G1. So send minus G1 to the left-hand side. So it's going to be positive. So G1 less than or equal to R1. And G2 less than or equal to R2. Okay? So add them up. I know that G1 plus G2 less than or equal to R1 plus R2. This has to be the case. So what do I know? G1 plus G2 is less than or equal to C. So here is the logical statement. I hope you can follow me. So remember, our starting point was the following. A public good is Pareto superior if there is some contribution G1, G2, such that these two inequalities hold and one of them strictly, which means public good is Pareto superior if the reservation price, the sum of the reservation price, is greater than or equal to the cost of the project. Okay? So, as long as the agent, so in this very simple framework, what is the utility functions? What is the specific utility? I mean, is it like Cobb-Douglas kind of utility function? I didn't say anything. All I said is that the utility functions are increasing. All right? So meaning both private consumption and public good gives more utility to the agents. So if this is the case, well then, regardless of how much wealth they have, well, public good is Pareto superior, I mean Pareto efficient, if, all right, so let's write it here, a public good, all right, public good is Pareto efficient, so PE means Pareto efficient, if the reservation price of the agents, here I have two agents, if I had n agents, it would be R1 plus R2 plus R3 all the way up to Rn. The sum of the reservation prices should exceed the cost of the, all right, so the sum of the reservation prices should exceed the cost of the public good. All right? If this is the case, well, then the public good is efficient. It makes perfect sense, right? I mean, think it this way. The reservation price is the highest price, the maximum amount of money an agent is willing to contribute for building this public good. So we calculate my reservation price, your reservation price, all the agents' reservation prices. So sum them up. That's the highest amount of money we can collect, we can gather, accumulate from those consumers in order to build the public good. We can't raise money more than that, because it means more money than that means some of the agents should contribute more than their reservation price, which in this case they're going to drop out and they're going to say, oh, you know what, I am against public good, because not having public good is going to bring them higher utility. Then, all right, so not having public good is going to bring them higher utility than contributing more than their reservation price. So when I add their reservation prices, that's the highest amount of money I can collect, gather, accumulate from those agents. Well, this highest amount of, assuming that the government is not one of those agents, all right? So if that total sum money is lower than the cost of the project, well, then we shouldn't implement that project. We shouldn't build this public good. When it is higher, well, it means the agents are actually willing to pay to finance this project. And hence it is efficient to have the public good. All right? So once again, a public good is Pareto efficient if the sum of the agents' reservation prices exceeds the cost of the public good. Okay? So that's it. So it's not always efficient to have the public good. The reservation price clearly plays an important role. So in order to determine whether a public good project is efficient or not, well, first of all, you have to calculate the reservation price of all the agents in the economy and then sum it up and compare this sum with the cost. If it is higher, if the sum is higher than the cost, it is efficient. If it is not, well, then it's not efficient. All right? So in the next video, I'm going to solve a specific numerical example. Hopefully will sort of make all those sort of equalities, etc., more understandable. All right, coming up next.